Hello students and welcome to T-Rex Math once again. Today we're going to be looking at our focus question that we started yesterday from Investigation 3, Problem 3.1. What quadrilaterals are considered reptiles? So just a little bit of a review. Yesterday we learned that a hexagon is not a reptile, and basically we know that it is a tessellation because it is a hexagon repeated into a pattern. But in order for it to be a reptile, it would have to look like this shape below, where the original is copied several times in order to make a similar figure to the original. So if this is the original that I shaded,
it looks like a window.
I can now make a copy of that by taking a combination of the same figure 4 times, and it now becomes a reptile. All right, so let's start with our first reptile or repeated tile, reptile number 1, which is a rectangle. So if we look at our rectangle here, if this is our original rectangle that I'm shading right now, it's a reptile because I could take that original and then copy it with itself several times to get a rectangle that's similar to the original. So if we look at our original figure and we look at the width of the figure, the original then, when it becomes a reptile, it now has a scale factor of 2 because the width is 2 times the original. And also, if you look at the length of the original in yellow, the copied image, the similar image, is 2 times the length. So the scale factor becomes 2, again, because it's 2 times the original. The page that you see here is linked in the lab sheet folder in Schoology, in the materials section of our Schoology page. I've also linked it today to the update, so you'll want to send this in to Notability to take notes while you're watching. So based upon the slide that you just saw, the note that you would record will be, here's your original, and you're going to turn that original into a reptile by drawing a congruent image of itself 4 times. It's not going to be perfect. Okay, the scale factor you would record is 2 because, again, the width and the length are 2 times the size of the original. Okay, the area of the original is 1 unit in the beginning, and then the area in the copied image, if each of these boxes has an area of 1, the area of the copied image would be 4. And then the perimeter, again, is the distance around, so if the side of the figure is each 1 unit, the original perimeter is 4, and then the perimeter of the copied image, you'll notice, is double, which is 8 units. So this is how you would take notes for the first reptile that you just saw. Reptile number 2 is a parallelogram, specifically a non-rectangle parallelogram. You could see in the original, if I go ahead and shade the original green, so there's my 100%, and then here it is in the diagram. So if I look more closely and check off or look at the height, of my parallelogram, you'll see that the height on the left is actually half of the height on the right. So we would say that the scale factor is 2 because the original had a length of, or a height of, 1 unit, and the copied image had a height of 2 units, so therefore the scale factor is 2. Now if I look at the base of the parallelogram that I highlighted in red, the base of the parallelogram in the copied image is found 2 times as well. So again, our scale factor then would be 2 because it's 2 times our original. Go ahead and fill this in to the worksheet that you sent to Notability. The area of the original figure would be base, which is 2 units, multiplied by the height, which is 1 unit. So the area would be 2 units squared. And so the copied image that's scaled larger would have an area of 4 times that, since there's actually 4 copies of the image, so it would be 8 units squared. Go ahead and fill that in on your note sheet. And then finally, the perimeter. If the perimeter is the distance around, and we were to count this as 2, and this is 1, and this is 1, and this is 2, we'd have 2, 4, 5, 6 units. And then the perimeter of this would have to be double, which would be 12 units. Again, go ahead and fill this in on your sheet just to keep track of what you've learned. This last picture here is actually pretty unique because if you look at the original figure, which is a trapezoid, trapezoid can be made into a reptile, but if you look at the picture here, this would not be a reptile because you can see that there's gaps right here and right here that do not get filled in. So this would be a trapezoid that could not be made into a reptile. This one, however, I worked a little bit more on, and I was able to get it to work. So if you are getting the trapezoid at just the right angle measures and side lengths, you'll see here that I was able to get the trapezoids to fit together. When you look at this trapezoid, you can see that I can move this around and see how many lengths fit in to both the base and the height of the trapezoid. See if you can work on this one and figure out what the scale factor is from the original to the copied image, and also the area and the perimeter. This is a more challenging way to think about reptiles. Once you've finished this tutorial, you'll want to go to the white binders and look at the book on page 52, and you'll want to work through problem 3.1, parts A through C. Okay. If you finish that and you have extra time, you can work on the ACE problems starting on page 60. Make sure to be collaborating with each other on this and making sure to show all your work in your math notebook so that I can see the work you've done. And my daughter Mia is helping me to record this, and she would like to say hello.
Hi.